Hello class, today we are looking at scale factor. The essential question is, how do I find the scale factor? Your learning intention: I am learning to find the scale factor of scaled figures and use it to find missing links. So we have two warm-up questions. Determine if the following sets of triangles are similar or not. So pause the video and see if you can figure out if these two are similar. Pause the video now, please. I hope you tried to do it on your own. So I want you to look at the first set of triangles. We've got two sides, so we can do two of the three sides for the proportions. But we've got to have all three sides for the side portion, similarity. If we can't do the three sides, we have to look and see if we have congruent angles. Do we have any angles in this picture that are congruent? If you said yes, you would be correct. These two angles are what kind of angles? Vertical angles. Angle MVL is congruent to angle TVU, vertical angles. Okay, now we've found that we've got vertical angles. We've got to look at the proportions that the sides are in. The question you have to ask is, do I want to go from side to side, or do I want to go from triangle to side to triangle, or triangle to triangle? Which way do you want to go? So if I was looking at this, I would realize that I will be putting 8 and 28 together and 14 and 49. That's one way to do it. Or 14 and 8, 49 and 28. That's the other way you do it. So if you're looking at this, I'm going to go from side to side. So I'm going to look at 14 over 8. 14 and 8 both have a factor of 2. So I can factor out 2 from top and bottom. 14 divided by 2 is 7 over 8 divided by 2 is 4. So this is in the proportion of 7 over 4. Is the other triangle in the same proportion? I'm using the biggest number over the smallest number, 49 over 28. 49 and 28 both have a factor of 7. 49 divided by 7 is 7. 28 divided by 7 is 4. So they're in the same proportion. That means those triangles are similar. So triangle MVL is similar to triangle. Okay, from M to V is the larger side, so it would be TVU by side angle side. Okay, that should have helped you. If you were not able to do either one, pause the video and see if you can do the second one at this time. Start off with congruent angles. You've got to have at least one set of angles congruent because you only know the lengths of two of the three sides. Do we have a congruent angle? Yes, we do. This is 76 and this is 76. So angle U is congruent to angle F. Now we're looking at sides. Do we want to go from side to side or triangle to triangle? Well, I think if I'm looking, this is 9 and 8. I know that 9 is 1/2 of 18. So 9 and 18 would be an easy fraction to simplify. 9 over 18. 9 is 1/2 of 18. Okay, the smaller side is 21. 21 over 42. 21 is 1/2 of 42. They're in the same proportion. The included angles are congruent. Triangle UVW is similar to triangle. From U to V is the long side. Long side, no side. FGH. By. Side, angle, side. So both of those were similar, and we proved it. Okay, so now let's go into scale factor. If you have not watched the video Scale Ella, I would encourage you to do that. Google it in YouTube and watch it. It tells you exactly what the scale factor is. So scale factor is the number you multiply the original length by to get the scaled length. So it's a number that you multiply the original length by to get the scaled length. Now it's important to realize you are always, always, always multiplying. Even if it is getting smaller, you are still multiplying. You're just multiplying by a fraction. So then the key word there is multiply. Okay, so let's find the scale factor of the following figures. So your original times your scale factor gives you the scaled one. So we need to pick a pair of sides. We can do 6 and 12, 10 and 20, whichever one we want. But the first thing we do is to identify the corresponding parts. So I'm going to use 6 and 12. Remember, we're multiplying. So the original 6 times the scale factor will give me 12. That's my scaled length. Divide both sides by 6. My scale factor is 2. So if you're wanting to set it up so you can remember it, the original times your scale factor equals your scaled one. You're always multiplying. Okay, what scale factors takes Hij to QRST? Once again, let's look for corresponding pieces. You can do any of them. So if I wanted to take 7, what side corresponds to 7? 21. We use our equation. So 7 times your scale factor will give you 21. We have to divide both sides by 7. And our scale factor is 3. Okay, pause the video. Now remember, it's telling you QRST. QRST is the first one to HIJK. So even though the arrow is going backwards, we're really going from the first one to the second one again. So pause the video, find matching sides, and then do the math. Okay, once again, I am going to use 21 and 7. So 21 times my scale factor will end up as 7. You still do the same thing. You are still multiplying, but your scale factor will be a fraction between 0 and 1. Divide both sides by 21. So my scale factor, okay, 7 and 21 both have a factor of 7 in them. 7 divided by 7 is 1 over 21 divided by 7 is 3. So this is a scale factor of 1/3. This figure is 1/3 as big as the bigger figure. What happens if it's a word problem? Well, you have to read. And then if you don't understand it, you read again. After you know you do understand it, you highlight what is important, and then you set up your equation. We are setting up equivalent fractions. So, Darrell measured a house and its lot and made a scale drawing. He used the scale 5 inches is equal to 3 feet. If the backyard is 65 inches wide in the scaled drawing, how many feet wide is the actual backyard? So as we're looking at this, do we understand what it's asking? Yes, we do. So let's highlight the important things. The scale is 5 inches to 3 feet. The backyard is 65 inches, and we want to know how many feet it actually is. 65 inches in the drawing, what does that mean? Let's start with our first fraction. 5 inches is equal to 3 feet. Okay, this is inches. I've got to match up inches with inches. Inches is at top. 65 is the inches. It will be at top. X will be at the bottom because we are looking for feet. 3 feet, how many feet? 3 feet, X feet. So we can do what we call cross multiplication. I start by multiplying at the diagonal. So to solve this, 65 times 3 divided by 5. And guess what you end up with? 39. But what does that mean? 39 what? 39 what? That should be 65 instead of 63. There we go. 39 feet. So the backyard was 39 feet wide. Okay, another scale drawing one. Can you set it up, or do you need a little bit more help? If you can set it up yourself, pause the video, work through it, and see if you've got the answer correct. If not, then we will go ahead and work together. Hakeem drew a scale drawing of a neighborhood park. He used the scale. 5 inches is equal to 2 feet. A soccer field in the park is 130 inches wide in the drawing. How wide is the actual field? So once again, we've read it. We'll highlight the important things. So he used a scale of 5 inches is equal to 2 yards. The soccer field in the drawing is 130 inches. 5 inches, 130, they correspond. How wide is it actually? Let's set up those equivalent fractions. 5/2 inches to yards is equal to 130. That's inches again. To how many yards? We do the same thing again. 130 times 2 divided by 5 equals. If you notice, we can do that all in one step. 52. What does that mean? Well, the actual soccer field is 52 feet wide. Okay, remember, word problems require a complete sentence for an answer. Okay, next one. After a long hike in a state park, Clayton decides to go relax at the beach. The parking permit he purchased allows him to park at any state beach without paying again. While consulting a map, Clayton notices that the closest state beach is 8 inches away from the park. The map uses a scale of 2 inches equals 1 mile. What is the actual distance between the state park and the closest state beach? Okay, so step 1, read it. Okay, I know what my scale is, 2 to 1. And I want to see what the actual distance is, knowing that it is 8 inches away. So the important things are 8 inches and 2 inches to one mile, and we set it up to find that distance. So the scale, 2 inches is to 1 mile as how many inches? Inches to inches, 8 inches over x. What does it look like when we do our math? 8 times 1 divided by 2. Did I have to put times 1 in there? No, but I wanted you to know that that was there. So this is 8 divided by 2, which is 4. What does it mean? It is 4 miles to the nearest state beach. Okay, we've got one more to go. Pause the video and see if you can read it and do it on your own, please. Okay, let's read it together. On a geographical map, a river running through Lee County is 5 centimeters long. The map uses a scale of 1 centimeter equals 13 kilometers. What is the actual distance between the river's source and its delta? The delta is where the river spreads out and is really wide. It might go into a lake. So how far is it from where it begins to where it ends with that lake? So as we're reading it through, we know that the river is 5 centimeters long. The scale is 1 centimeter equals 13 kilometers. And we want to know the distance or the length of the river. Set up our fraction. 1 is to 13. 1 centimeter is to 13 kilometers as. Well, this is in centimeters, so I know the 1 and the 5 have to be in the same spot over x. Once again, we can do that cross multiplication. 5 times 13 divided by 1. Do I need to divide by 1? No. I'm putting it in there simply to show you that it's supposed to be there. And we get 65 for our answer. But what does the 65 mean? Well, it means that the river is 65 kilometers from its source to its delta. Okay, so I know I'm successful when I can find and use scale factors in problems. So we are finding the scale factor. We are solving equivalent fractions. And then we're deciding what they actually mean.